Hello, students. In our previous lessons, we have talked about motion, how things move, their speed, their acceleration. But have you ever paused to ask a more basic question? Why do things move at all? What makes something start moving or stop moving? Today, we begin our journey to find the answer to this very question. So, here is a quick look at what we will cover today. We will start with the old mystery of motion, and then we'll meet the main character of our story, force. We will see what happens when forces are balanced and unbalanced, explore a brilliant idea from Galileo, and finally, we will understand Newton's first law of motion, which is all about something called inertia. So let us begin with a puzzle that confused even the greatest thinkers for many, many centuries. What is the real reason for motion?
Think about it. I'm sure you have all experienced this. When you roll a ball or push a toy car on the floor, it moves for some time, and then it slows down and stops. Why does this happen? What is it that brings the moving ball to a stop?
Well, because of what we see around us every day, it seems obvious that objects just prefer to be still. The state of rest seems to be their natural state. This idea seems quite logical, doesn't it? Something will only move if you keep pushing it. And for a very long time, this is what everybody believed. But what if this simple, common sense idea was actually incorrect? To really understand motion, we need to introduce the hero of our topic today, and that hero is force. So, what exactly is this thing we call force? Can we see it? No. Can we hold it? Not really. Force is something invisible. We can only see what it does. In the simplest terms, a force is just a push or a pull. When you push a heavy box, you are applying a force. When you pull a chair closer, you are applying a force. When you kick a football, that's also a force. So you see, force is what causes a change.
So let's look at all the things that force can do. A force can make a stationary object start moving, like when you kick a football that is on the ground. A force can also stop a moving object, like a goalkeeper catching that same football. It can change the speed of an object, and it can also change its direction, right? Imagine a cricketer hitting a fast bowled ball and sending it towards the boundary. The force from the bat changes both the speed and the direction of the ball. And a force can even change the shape of an object. Think about what happens when you stretch a rubber band or squeeze a sponge. That change in shape is because of the force you applied.
Okay, but what happens when we apply a force, but the object doesn't move at all? I'm sure you've pushed on a heavy wall, but the wall doesn't move, right? This brings us to a very important concept, the difference between balanced and unbalanced forces. Let's picture a game of tug of war. If you have two teams and both are pulling the rope with the exact same strength, what happens to the rope in the middle? Absolutely nothing. It doesn't move left or right. This is a perfect example of balanced forces. This is the key idea. Look at the left side. Let's imagine you are trying to push a very heavy box across a rough floor. You push gently, but the box doesn't move. Why? Because there is an invisible force, the force of friction, which is pushing back with an equal and opposite force. The forces are balanced. The total or net force is 0, and the box's state of motion does not change. But now, look at the right side. You decide to push much harder. Now your pushing force is greater than the force of friction. The forces are now unbalanced. There is a net force in the direction you are pushing, and the box starts to move. So, this is the most important point to remember. For any object to start moving or to stop moving or to change its direction, there must be an unbalanced force acting on it. If all the forces are perfectly balanced, then nothing changes. The object will continue doing whatever it was doing. So, for centuries, people thought you need a continuous force to keep something moving. But then a brilliant scientist named Galileo Galilei came along, and his very clever thought experiments completely changed how we think about motion.
Galileo started with very simple observations. He took a ramp, or an inclined plane, and let a marble roll down. Of course, it speeds up. Then he let it roll up another incline, and obviously it slows down. But then he did something clever. He let the marble roll down one ramp and then up another one. He noticed that the marble tries to reach the same height from where it was released. The only thing that stops it is friction. And here comes his brilliant question. What if, after rolling down the first ramp, the second surface was perfectly flat and perfectly smooth with no friction at all? The marble would want to go back to its original height, but on a flat surface, it can never do that. So what would happen? It would just keep on rolling forever and ever. And this led to an amazing, revolutionary conclusion. An object does not need a force to keep it moving.
The only reason things stop in our real world is because of that unbalanced force we call friction. If we could create a perfect frictionless surface, an object that is moving would simply stay in motion at a constant velocity forever.
Now, this amazing idea from Galileo was taken up by the great Sir Isaac Newton. He refined it and presented it as his very first law of motion. This law is all about a property that every object has, a property called inertia. This is Newton's first law. Let's read it carefully. It's basically saying that objects are a bit, well, stubborn. If an object is at rest, it wants to remain at rest. If it is moving with a constant speed in a straight line, it wants to continue doing exactly that. The only way to change this is if an external, unbalanced force acts on it. And this natural tendency of an object to resist a change in its state of motion is what we call inertia. You can think of it as a kind of laziness. Objects do not like to change what they are doing. If they are resting, they want to continue resting. If they are moving, they want to continue moving. That is why Newton's first law is also known as the law of inertia. You feel inertia all the time, every day. Imagine you are standing in a bus and the driver suddenly applies the brakes. What happens? Your body jerks forward. This happens because the bus has stopped, but your body, due to its inertia, tries to continue moving forward. The opposite happens when the bus starts suddenly from rest. You feel a push backwards. Why? Because the bus has moved forward, but your body, due to its inertia, wanted to remain at rest. This is a wonderful experiment that shows inertia in action. If you stack up some Karm coins and then hit the bottom coin very quickly with a striker, watch what happens. The striker applies a force only to the bottom coin, so it shoots out. But what about the rest of the coins in the stack? No force acted on them, so because of their inertia, their tendency to remain at rest, they are left behind and simply fall straight down. It's a perfect example of the law of inertia.
So a good question is, do all objects have the same amount of inertia? Think about it. Is it easier to push a bicycle or to push a whole train? Of course, the bicycle is much easier to move. This is because the train has much more mass. So the important relationship to remember is this. An object's inertia depends on its mass. The more mass an object has, the more inertia it has, and the more it will resist any change in its motion. All right, that was quite a lot of new information. So let's just take a moment to quickly summarize the most important concepts that we have learned in this lesson. So what are the key takeaways? First, a force is a push or pull that can change an object's motion. Second, and very important, it is the unbalanced forces that cause a change in motion. Third, all objects have inertia, which is their natural resistance to change. Fourth, an object's mass is a measure of its inertia. And finally, all of these ideas are put together beautifully in Newton's first law of motion. And to finish, I will leave you with a question to think about. Imagine a small bullet and a very large truck. And imagine they are both moving at the exact same speed. Which one would be harder to stop? And more importantly, why? Think about what you've learned today about mass and inertia to figure out the answer. We will discuss this in our next lesson. Thank you for your attention.